Hello guys, today we're gonna build microservices application using Java and Spring Boot. Let's assume we have a simple application and we're gonna just implement only one feature of that application. We have a customers which makes some orders, and after customer made an order we need to send him a notification, for example email notification. And let's just try to implement such functionality. Before we start, we need to generate empty Spring Boot projects. I navigate to Spring Starter, as I usually do when I need a Spring Boot empty project. First application is gonna be customer app. And let's add some dependencies for customer. Let's add Lombok dependency. Let's add GPA dependency. Let's say we wanna store some order in the database. Let's add some web dependency. And for the microservices, we're gonna need an Eureka for the future. And let's think what else do we need in our application. Let's add in-memory database. And I guess that's it. Let's click generate. And let's generate another application which is gonna be notification app. Let's say our notification app will just receive a request to send notification for customer and just for example send some email. And let's remove GPA and in-memory database dependency. We're not gonna store notification results in the database, but yes, in real project we usually store notification results. Okay, let's click generate. Okay guys, our projects are opened in the preferred IDEA. For me it's IntelliJ IDEA, and now I'm going to implement my functionality. What is microservices actually? It's nothing but small services which communicate with each other for some functionality, for some data. In our case, we have just two applications, just for simplicity. In real projects, you can have 20, 50 applications which communicate with each other in different ways. As of now, we gonna implement only one functionality, but imagine a complex, a big application which communicates with a lot of modules, with a lot of independent modules, and it shares some information, it shares some data between the applications. I'm not gonna tell you the pros and cons of microservices. All that stuff you can read on the internet. I just want to show you a hands-on example how this works like in the real projects. Okay, let's first navigate to the customer application and try to create some controller which gonna receive create order request. Let's create order controller. I hope guys you are aware of REST controller annotation, SL4G from Lombok, and all our constructor also from Lombok. It's just to all RS constructor is just to wire through the constructor the dependencies. SLFG is just for logs and request mapping and just order, and let's create post mapping. We're gonna send back order ID, and we're gonna receive order DTO. Let's create order DTO. Let's add some fields for the order. It's gonna be customer ID, and let's say some comment. I'm not gonna stop on this stuff because I already recorded the videos according REST, according services and endpoints. I'm just gonna use all this stuff we learned previously. Implements order service. Let's just add service annotation, Larks constructor, annotation for logs, and let's try to implement this create method. Okay, we agreed that we create a record in the database and then we send a notification to the customer. Firstly, let's try to store our order in the database. Let's create some package and let's add order model. Let's add data, entity, table, and let's add ID, generated value, and let's try to add customer ID. and some field like date creation. And let's add repository. Sorry. If you want to know more detailed about all that stuff with repository, there is a lesson on our channel. Just take a look on the recent videos. I explain all this stuff. Okay, our repository is ready, and we are ready to save our order in the database. Okay, we need to convert order DO to the order model. And I guess that's it. We can save. Let's set a wire our order repository. Let's try logs in our controller first. I want to add more logs here because recently I want to add Sleuth to our microservices application to show you how it works. So that's why I add so much logs. But on real projects you don't need so much logs, especially if they are useless. And that's our basic implementation. Let's try to send the email. And firstly, let's navigate back to the notification app. And let's add some controller which will serve our send notification. Let's add method which will serve email notifications. it will return nothing, just void method. It will receive notification params like email of customer and body of the email. Let's make it email and body, and let's create some service which we are gonna use to send notification. We're not gonna send this notification to the real email. For those of you who are curious, we have a special video. All the videos I put in the link to this video, and we have special videos how to send email using Spring Boot and Gmail. So for those of you guys who want to finalize the implementation of this feature, you just add some send email functionality, but for me to simplify this video, I just add some logs just to see that this email reached this line of code. Let's say sending email to, or something like that. I guess that would be enough for the learning purposes. Let's add in this video I'm also gonna use some validations or other stuff, but you when you will work on this example, you can add some validation stuff. Okay, I guess with notification that's it. As we're gonna have two applications running on the same local machine, we need to change the default port on at least on one of the application, because as you know, Spring Boot runs on 8080 default port, and Tomcat Spring Boot runs on 8080 default port, so one of the machines should be on the another port. So we're gonna change server port from 8080 to, for example, 8088 for notification app. And as for now, that's it. We can start the application and see if it runs successfully. Yeah, we added discovery client, but as of now, we can comment this dependency. Okay, our application is started, and I'm gonna look through this issue because it's maybe some IntelliJ IDEA cached this dependency. I'm not gonna waste my time on Maven clean install. Our application is started and ready to accept the notification request. Let's get back to the let's firstly notification email. Let's remember this notification email URL, and let's get back to the customer and let's try to write some client. How we gonna communicate with notification app? And let's add some and let's get back to our notification client and let's add, for example, one method, send email. Email DTO. One of the minuses of microservices is data duplication. We created email DTO on the notification app, and we also need to create this class in the customer app. Some teams creates libs with all the dependencies like email DTO with all the common objects, but I'm not gonna use don't like this approach because sometimes it's really hard to update these libraries, and every time you add one dependency, for example, you need to add this not a dependency, once you need to add one object, you need to update the library, and it's really hard to trace the library updation on every project to keep the library is up to date. So sometimes that data duplication is not the worst thing that can happen with microservices. So let's add string email and private string body. And actually I forgot, we need also some sort of things like subject of email, but for this testing purpose we're gonna leave it as empty. So let's navigate to the notification client and let's implement this send email service. So what we're gonna do, we're gonna use RestTemplate. There are a lot of methods, a lot of libraries to communicate between applications, and one of the approach is using RestTemplate. RestTemplate is nothing but a class from the I'm not sure exactly, but I guess from the Spring, which will help you to invoke other endpoints from the other services from the it even can invoke endpoints on the internet endpoints or other stuff. So let's firstly add a bin for the RestTemplate dependency. Let's create a package and let's add we need to mark this configuration as configuration, and Spring will see this configuration annotation and will load this class in the context on startup. And let's add a bin. Yeah, it's a dependency from the Spring. It's just a new REST template. If you need, for example, a REST template with authentication stuff or some filtering stuff, you can add all that functionality in that bin creation method. But as of now, I want just to show you microservices simple approach without authentication and other stuff. By the way, I saw a lot of projects with unauthorized endpoints just because some internal services are not open on the internet, and you don't need to worry about such things like authentication or security. Okay, we created a REST template bin. Let's auto-wire it. Let's call it component. Let's call our notification service. Notification client is component. Add ORS constructor, self-gym, and auto-wire REST template. And REST template has some intuitive methods which you're gonna use. Let's firstly something like that. And let's go REST template. And let's see what do we have here, because I'm not remember which method exactly do I need. We need post method because our notification is using post method. We can use post for location. And in the first param we're gonna say URL, and in the next our object which we're gonna send as body of the post method. Let's add URL. We can avoid hardcoding, just set the URL of our notification application in the resources. But lately I'm gonna use Eureka discovery client. So for now I'm gonna hardcode this value. So we set 8088 port, and we're gonna send our request to the notification email. And actually that's it. Let's try to add this notification in this service. Let's prepare email DTO. And yeah, we need to store somewhere customer email and customer ID. Let's create some model. Now let's copy paste annotations to save some time. Actually, it's a bad practice copy pasting, but as of now we can do it in the testing purposes. And that's it, I guess. Let's add some name for the customer. Well, let's add customer repository. Okay, let's navigate back to this service and let's add some let's first, before saving our order, we need to find the customer. And this for this purpose we actually need some customer service, and then in our order service implementation we need to use a customer service instead of customer repository in order to avoid mixing up the repository of customer in the order service. But for our purpose we can do as of now, and it also looks okay. So let's try customer model equals customer repository find by ID order get customer ID. Otherwise, if we don't haven't found, we just throw some exception. I'm gonna throw a legal argument exception. Something like that. And we have a customer or a model. And we need to prepare some body of the email. Now let's create some interesting body. For those of you who are not aware of string formatter, it's just a simple way to format a string. Instead of these symbols, we're gonna paste some data. Instead of first one, we're gonna say customer name. Thanks for your order, username, your order is, and number of the order. It will look pretty good in the email message. So customer model get name and created order, save order, get ID, and is our body. And we are ready to send email DTO. Let's move to the separate method. Let's call it prepare and send email, and we can also move this and make our code more readable. Look pretty good. Okay, let's add some configuration for the database. Okay, let's add Spring data source. Oh, I just need data source URL equals gdbc h2. Let's call it testdb. And I guess that will be enough. And to avoid using Postman, let's add some Swagger UI for our application, especially considering the fact that in the previous video we got some knowledge how to add just one dependency and use Swagger UI. Let's get back to our previous project. And I added this dependency OpenUI, which enables Swagger UI. Let's add it to our project. And let's try to make to start the application and see if it will work for us. It's a problem with Eureka. I think it will work even without the Eureka server. Let's try and use this browser. So our service is working on 8080 port, so we're gonna say localhost 8080 Swagger UI HTML. Oh, it's not found. Let me check. Let me check in Chrome. Localhost Swagger UI HTML. I guess IntelliJ IDEA cache some data, or it's my Maven. Let me make some clean install. Previously this didn't happen, but from the last update of IntelliJ IDEA these things happen, and you need to be aware of that also. Okay, clean install. Let's restart our application. Okay, let's try once again. And now we have our UI. Okay, let's try to create some order. What's that customer? Oh yeah, we don't have a customer yet, and we will receive an error. So let's just check if we receive an error. We gotta receive an error. Yeah, we receive an error that customer is not found. Let's add some customer. I'm not gonna add this functionality to add a customer. Let's just add some config file to create some default customer on application startup. Let's add some bootstrap config. Let's add some configuration. Let's say as we need to add customer repository, and we need to add listener ApplicationReadyEvent. This annotation will work after application starts. Create customer, and let's create some customer. Let's add some John Snow name, and let's add some customer email, John gmail.com, something like that. And let's say customer repositories, save our customer, and every time we will start our application, this customer will be created, and as we use in-memory database, this customer will always have ID 1. Let's restart. Okay, let's try once again. And as you can see, we successfully created our order. And let's see if we send in an email. Looking through the logs, we navigate to the order controller first. We have our customer request, found the customer, and save an order to database, and then send an email. And if we navigate to the notification app, we see a lot of errors, but among the errors we gonna see our email. Okay, let's handling an email request. So here we see request for sending email with our body and other stuff, and we see that we invoked send email in our email service. And that's it, and that's actually how microservices work together. It's just separate applications which exchange the information and invoke. Instead of invoking the method like in the single application, microservices applications invoke endpoints of it's not usually REST endpoints. In our example, we invoke REST endpoints, but sometimes they invoke some asynchronous endpoints like Kafka, listeners, and other stuff. But yeah, in this example, we just invoke REST endpoints. But that's the easiest part of microservices. It's not very good to hardcode the actual URL of services in the clients. Actually, it's a really bad practice, especially considering that applications usually runs on some containers like Kubernetes, like Docker containers in Kubernetes. And these containers have dynamic IP, so you can be sure that your notification application will have like localhost IP or other predefined IP. And that's when the discovery clients and discovery services are come in handy. Now I'm gonna create some Eureka discovery service and show you how can I register my applications in discovery service and then communicate between the applications by the service name instead of service IP. Let's navigate to the Spring Starter and create one more application. Let's call it Eureka Server. And let it be just Java11. In this Eureka server, we just need one dependency, Eureka. Instead of Eureka Discovery Client, we select Eureka Server. And let's click Generate and unzip it. And let's open it in our IntelliJ IDEA. Okay, our Eureka server is opened, and in this application, will just serve like server registry. This application will be listening to our services and register them, and it will give them dynamic APIs. Okay, it's better to show you on practice. I'm not gonna add any classes in this Eureka server application. I just add enable Eureka server annotation to tell the Spring that I'm gonna enable Eureka server, and I'm gonna add some property file. I'm gonna say that this application should not try to enable itself as client. By default it's true, but we need to set it as false because we need this application to be just like a server. And we need to set that we don't want to fetch registry for this application. And I'm gonna set the port of this Eureka server as 8761. And that's it. Let's try to start our Eureka application. Okay, it started, and if we navigate to the browser and try to navigate localhost 8761, we will see the UI for the Eureka. Let's try. As you can see, here is our Eureka UI, and here are instances register with Eureka. As you can see, it's just one unknown. It's, I guess, Eureka itself, but I'm not sure what is that. Maybe it's actually our notification app has registered itself, because I can see 8088 port. For now it's unknown, but we're gonna change it. Let's navigate to our notification app. I guess if we reload the page, our next application will join the list. Okay, yes. Here we see two applications. This is my API. Let's navigate firstly to the notification app. And one thing we need to do is just to say that Eureka identifies our application as unknown because we haven't specified application name. We need to specify this application name in application properties or in Bootstrap file. Spring application name, and let's call it notification app. Let's save. Recently, we need to add some annotations like enable discovery client or enable Eureka client. But as you can see, as of now, you can see that it doesn't need it anymore because once I started Eureka server, our notification app registered itself without any additional annotations, and that's really cool. Let's restart our application, and you can see that our notification app has registered itself in the Eureka server. And the same thing we can do with our customer app. And what this actually gives us. As of now, instead of hard coding this localhost in the notification client, we can use Eureka, not Eureka, just application name. Instead of localhost, we just need to use notification app. And to make this work, we also need to navigate to our RestTemplate configurations and enable annotation load balancer. And this load balance will use Eureka as we have this dependency in our POM XML. Okay, let's restart our application and see if it will work as it worked previously with hard-coded localhost. But as of now, we just gonna use service name. I forgot we don't need this port anymore also. Now let's restart once again. And I guess I made a mistake. We need to restart once again. Okay, let's check our Eureka. As you can see, we have customer app and notification app. Let's get back to our Swagger and try to create some order. Let's try to execute, and we see successful response. Let's check, and yeah, as you can see, we have the same logs as previously. Let's navigate to notification app, and you can see that our notification app received the request, but for now we used service name instead of hard-coded API. The next thing which is you should consider when you make a microservices application is logs. It's really hard to find out what is going on in the microservices applications because logs can store in different places, and logs without any configurations, logs are not connected with each other. So this is logs from the customer app, and this is logs from notification app. And let's just imagine you have a big application which use a lot of people, and you need to find some initial request, and then you need to find the path which this request followed through the applications. For that purposes, we add the trace ID and span ID in the logs message to easily find the connected logs between the microservices. There are a lot of techniques to do that, but the easiest way to use Spring Sleuth to enable these IDs in the logs. Just adding one annotation will give you out of the box span and trace ID in the logs. Okay, let's try to add this dependency in the POM XML and check how it will work. Firstly, as you can see, my IntelliJ IDEA cached, and this didn't help. This commenting didn't help to prevent Eureka. Okay, as of now, we don't need to comment it anymore. Let's add one dependency. Okay, let's add a Spring Starter Sleuth dependency. And let's add this dependency. Let's make Maven clean install to avoid some caching. Let's restart our application. And while it's starting, let's get back to the customer app and add this dependency to the customer also. And let's make clean install here also. Okay, we can restart it now, and let's check our notification app. It started successfully. Our customer app is starting now. Okay, our application started successfully, and let's try how Spring Sleuth works in action. Let's get back to our, it's our quick time. Let's get back to our browser and try to execute request once again. Here we have request and response. And as you can see now in the logs, we have customer app is our Spring application name from the application properties. Here is trace ID and here is span ID. As you can, if you it's just generated values, and if you check this value in the notification app, this value will be the same for the same request. As you can see, this request is just for these two logs. If you make some, for example, some more requests, I don't know, let's say you have a lot of logs and you have find some special request and some special trace. You can just select this span ID. Actually, I'm not remember exactly which one is span ID, which one is trace ID. You can find this information on the internet, and you can just search all this stuff in the logs. And that's how Spring Sleuth works. And this technique gives you real understanding of how the request followed through the microservices, especially if you have, for example, not 2 but like 10, 20, 50 microservices. And yeah, especially if you have some YLCAS stack, and it's easy to trace these logs using these identifiers. Okay guys, that's it for today. I hope now you understand the microservices and you can get this example as a starter point of your microservices application example. Don't forget to subscribe to the channel. There will be a lot of videos which I'm preparing for you. Stay tuned. Goodbye guys.